A conference where we are ahead of schedule, perfect. So thank you for staying with us. We are now at the final slot. So we will just give us 1 second to put up the technical setup, and we will also show you a demo. That's why we will handle it like this here.
Okay, sorry, 1 second.
Yeah, so please take.
Perfect. So we are talking about intent-driven automation for machine data from natural language to edge deployment. And yeah, as you see, we are two. So if we move on. So my name is Verena Pietsch. I'm from Phil, which is a mechanical engineering company based in Upper Austria. I'm a data scientist there, and I will show you afterwards the use case we are presenting. So we are working together in an European project, and I will show you the use case, and my colleague will show you afterwards the technical details.
Yes, so welcome also from my side. My name is Toma. I'm the Chief AI Officer of Onlim GmbH. We are an Austrian SME with offices in Innsbruck and Vienna. And what we do is conversational AI. We built a platform, a software as a service solution that allows you to create chatbots, voice assistants, and we will give you a demo just to understand a bit what we do, more specific in the context of the intent project and particularly for the field use case.
Yeah, so as I said, we are a mechanical engineering company, but our customers expect more than machines. They also expect, of course, digital solutions and products which add real value to their production. But implementation and the deployment is often technical, complex, and takes time. Because as we are a special mechanical engineering company, we also need to adapt to the different requirements of the customer and also to the specifics of a machine, and that's why it gets complicated. You have to select, and you have to select the right containers, the right services to solve the problems of your customers, configure it to the specifics of the machine, and you get it. You need quite some domain knowledge. But now, what would happen? So if we just give a tool to our customers, and the customers can just express their problem and just tell us what they want to analyze and what they need, and we just deliver the solution and to help them analyze the problem right to their machine. And that's where the intent project comes in. Because here we have a vision of a digital service portfolio that explains itself. So intent tools enable intent-based interaction with the machine data services. The user just use natural language to express their problems, and the service understands the intent and automatically orchestrates the relevant services and data processing. So that's what we are doing basically in intent. And now I was talking quite a lot about intent, but now I will like to show you what we are doing here. So in a nutshell, we are bringing human-like intelligence to the computing continuum. So basically everything which consists out of edge, far edge, cloud, everything in between, and we're trying to orchestrate with human intelligence the systems so that it can adapt like a human, think like a human, and talk like a human. So the idea is it adapts in the background the processing pipelines you need, think like how you need it, and then explain to you what happened in the back, so that it's trustworthy and you can trust the solution. So that's intent, and as I said, it's a Horizon Europe Research and Innovation Action, so where we are collaborating with 16 partners from 13 countries, including Europe and also South Korea. And today we are 2 representatives of the project here, and we will show you the use case in more detail. So what we are showing you today, so we have a customer here, and the customers, they have some problems, some specific problems in their production. So for example, we have problems with the time of the life of our tools. And then usually they call within our after sales. And then it gets complicated, of course, because then we have to analyze everything, you need to get the data. But actually, we already have some tools in our portfolio that would serve the purpose. So now their intent gets into play. And for what happens in the back, basically, what happens, so we will deliver the solution to the customer, but what happens in the back, I will hand over to Ioan.
Yes, thanks, Verena. So I want to give you a bit of insights of what was the technology behind and what exactly we are doing in the back to support such use cases, right? So there are basically 4 steps that are relevant here. So on one hand, we try to understand the user request, and of course the user request comes in natural language, so the user is speaking freely, trying to get the system to solve the problem he has. What we do afterwards is we have in the back a knowledge graph. We use a knowledge graph for semantic interoperability. So think about all the relevant entities for this particular use case. I mean, the services, the different components, the different containers that are needed to support the whole use case. They are all represented as knowledge and are available in a knowledge graph. And we make use of this knowledge to basically understand what the user requests and also to configure basically the appropriate workflow that will help with the automation of the full pipeline. And then in the end, we also generate Docker commands and we are deploying the things on the different machines on the edge infrastructure. So a little bit of details for each of these steps. So as I said, the first step would be to understand what the user is requesting. Here we make use a lot of large language models, basically to interpret or to extract the user intent, to understand what type of things he's looking for, what are the parameters that are relevant, what are the things that should be extracted in order to understand the intent of the user. We of course maintain the context, the dialogue, all the information that was exchanged between the user and our system. We also support various channels. In the demo, I'm going to show you also a voice bot, but also a chat widget, so the user can interact through these various channels. And all this is used to enable natural language interaction with the intent toolbox. As I mentioned before, we make use of a knowledge graph, and here we have different entities, relations between them. What we are using is standard semantic technologies. We have RDF repository in the back. We present or we store this type of information as RDF triples. We can serialize that as JSON-LD. We have validations. We're using Shackle. And of course, you would have to create such a knowledge graph in the beginning, and this is what we do for the field use case. I'm going to show you briefly how this looks like. And then we do a sort of a RAG approach using the knowledge graph. We call this graph RAG to extract the relevant information from the knowledge graph and to provide that as input for the LLM to generate answers. The third step would be this automatically generation of the appropriate workflow. So we translate these intents into data-driven analytics workflows, and this is something that adapts the workflow to the different machine types, processes, and infrastructure. And the very last step, as I mentioned before, is actually the deployment of these workflows on the machine edge, on the continuum. Good. So I would like also to show you a small demo on what's available so far. A second. Okay. So yeah, that's basically our environment. You can you have different functionalities here, but what is relevant for now is this chat widget. Is one of the channels that one can use to interact with our system. So this can be easily integrated in a web page or in any other environment where the user is actually using or wants to interact with our system. And then you can ask, as I mentioned before, in natural language or something like, I know, show me. So this is actually querying in the back the knowledge graph and will get the relevant information and show the data, right? So these are all the services that are available. Of course, you can also ask, yeah. So you can have this type of interaction, writing questions in natural language and accessing the knowledge graph. I want to show you a little bit also the knowledge graph part. It's a bit hard from here. Yeah, so the knowledge graph, sorry, the content part here for the knowledge graph. So for example, here we have the data that is relevant for this use case. So let's say I'm interested in seeing first some services. I can explore these services also in this graph view. Then I can look at different other things that are related to that. So yeah, that's more or less the knowledge graph interface. And last but not least, I would like also to show you this agentic voice channel that we have. So you can also talk basically to the graph. So I'm not sure if we can hear, but in cases. No. 1 second. Just one. Okay. Yes. 1 second. So, and where exactly? Let's try again.
That's research and innovation.
No, it doesn't work. But maybe I will use simply the mic to. Maybe this one. Should I use the speaker and we can actually use the. Okay. Okay. He's still talking to us in the background. Good. So let's end the conversation and we start again. Yeah, okay. Can you tell me what services are available for the field use case?
Here are available services for the field use case. First, prod data records components and analyzes production status. Second, machine state shows live production status. There's also energy tracker for monitoring media consumption, KPI analyzer for efficiency reporting, and alarm analyzer for alarm causes. Need more details on any of these?
Yes, I would like to know more about the alarm analyzer.
Sure. The alarm analyzer records all alarms and messages,
Can you tell me maybe what components are relevant for this analyzer service?
The alarm analyzer service uses component 6 as its main element. For example, it relies on that component to capture and analyze alarm data. Anything else you want to explore on this?
Yeah, I would like to know, maybe which container can be used for component 6.
Component 6 can run inside container 30 for some services. For example, alarm analyzer might use that container. You want more details on deployment steps?
I would like you to help me with generating the Docker commands for deploying this analyzer service.
Understood. Here's how you deploy the alarm analyzer. First, pull the image. Docker pull link to build Docker registry 5050 alarm analyzer. Next, run it with environment variables. Docker run alarm analyzer. Underscore n file fill in variables file.
Great, thank you. Thanks a lot.
You're welcome. Is it all clear now? Or do you have any other follow-up questions?
No, that's all. Thank you. Or maybe the audience has questions.
Just to confirm, is it okay if I close the conversation now?
Yes, it's okay. Thank you.
To keep the human in the loop.
Have a great day.
Yes, that would be our part. One more slide with conclusions. Oh, sorry.
Yeah, so the project started last year. We are currently in the middle of the project, and it still runs until the end of next year. So we still have some time to develop all these different steps we still need to deploy on the edge. But we are quite far, I would say. But what happens, what's the vision of the use case? So what used to take days is now done within minutes. You saw just in the demo how fast you can just generate the Docker commands for the relevant components and the relevant containers you need to deploy your service on the edge. And you don't even know which containers are relevant for you, for the service you want to deploy and for this problem you want to solve. So you have reduced deployment times, you have a greater adaptability to customer needs, you have a democratized access to data analytics services, as you can also involve now the after sales and also the sales. And you have intelligent automation supports the sale efforts. So our sales can just now sell and already deploy within minutes. And that concludes our presentation. So you just here have some more information. So if you want to get to know more about intent, here's the link where you need to go. And that's all from our side. So we will thank you for the attention. Thank you for bearing with us in the last slot of the day. And we are happy to answer any questions if you have.
Thank you.
Thank you. Thank you so much. Is there any questions? Oh, yeah. I see it here.
So thank you very much. Could you maybe please let me know a little bit about your knowledge graph? Maybe I missed, from where do you get the data? Is it the documents about all the machines? And also, is that human annotator or any kind of ontology? How this works, basically?
Yeah. Yes. So together with Verena, so we got from Phil a couple of data sets which are more or less unstructured, right? So there are information regarding the different configurations, different services, containers, and so on. You can also, we didn't showcase that part, but you can also have documentations on how to use various services and machines and so on. And all of this information, what we do afterwards, we are extracting information from there, right? We know that, so again, with the help of LLMs, there is some knowledge extraction pipeline in which you can feed this data, this information, and we can generate the knowledge graph based on that. Of course, the knowledge graph, I mean, for that we already developed a certain model ontology in which, you have entities such as service, container, components, each of them with different properties. So we have a vocabulary or ontology. We also have for each of those entities, some we call them domain specifications, but actually what they are shackle shapes that allow you to validate if the data that is coming in is valid or not. So for example, I know the service can have only one name, or it should have one name. So you have some cardinality constraints that you specify in these shackle shapes, and then when the data is pushed into knowledge graph, so again, extracted from these various sources, and then pushed into knowledge graph according to a certain schema, right? So, and then, yeah, you have the knowledge graph. There is also the option, I didn't show that, but one can go and as you saw the knowledge graph, it can be also modified. You can also run queries to see, to get information out of that, Sparkle queries, and so on. But that's basically the pipeline, yeah.
Thank you for the question. Is there any more questions? I don't see now, so thank you both for inspiring talk. And
Thank you.
with that, I would like to conclude the day first of DSC DACH25 conference. Thank you for spending the day with us. We hope you find it valuable, insightful, and energizing. We look forward to welcoming you back tomorrow at 9:30 for another day full of great talks, discussions, and connections, and just having fun together. So thank you once again, and see you tomorrow, hope.